Hello, everyone. Welcome to Methods 2, Week 4. Now that everyone has become familiar with your chosen building and created a general massing, I would just like to recap last week's assignment and show you what I have created for the tea house. So, first, we start off importing our necessary reference images. For instance, this is the plan. And I'll just turn on these layers that I've already created, starting to sketch out the outline, the basic outlines that we need. For instance, all I've done on this is just outline the first floor plan. I have also included a second floor plan directly on top of my first floor plan. As well, if I go to the perspective, you can see that it is on top of the first floor. I have also added the section and elevation. And I will turn on my section outlines. As we can see, we have all the necessary framework to create this building. So with those curves and elements, I was able to extrude this massing. Now let me turn off all those outlines and images. And we're able to get this very simple, solid massing. All of this is considered as one closed solid poly surface. The way I did that was by extruding individual elements to create various extrusions and then Boolean unioning those together to make them all one object. And then you can use the command merge all coplanar faces shown at the top. That will clean up all the geometry that you see. So we no longer have like certain lines where the previous geometry came together. Now moving forward for this assignment to part 2, we are taking this general massing, this first exploratory method in 3D modeling, and we will be developing it further to have a very detailed final model of your chosen building. So for instance, when I look at the elevation for this tea house, I am able to see that there are a series of windows along all elevations. And in particular, we're going to be focusing on this side elevation right now. So if I go back to my top view, I have replaced or put the elevation back on the top view because it's the easiest and most well known in dealing with 2D line work. I would say it's the simplest even. And what we can do is start outlining where these windows are in relation to the facade. So first I'm going to draw my reference rectangle, which is the reference for this corner being the same corner that's represented in that massing. Now I will start drawing these windows. And again, when we're just guesstimating right now, it doesn't have to be exact. But what we can see that's pretty exact is all of these windows are the same size as well as being equally spaced apart. I even go as far to say that the tops of these windows all align across this elevation. And if I draw a line like I just did, hold shift to temporarily turn on my orthographic, and hold and press tab, it will lock that direction that I'm drawing the line in. And if I drag it all the way out, we see in fact that all of these windows line up their topmost mullion. I also want to be reminding y'all to make sure you have your O snaps turned on. Just because the O snap down here is highlighted, you need to make sure that you have all of your necessary object snaps turned on. For instance, the end, near, mid, intersection, and perpendicular. That's the ones I'll be working with right now. As a general rule, those are the main ones that you should probably be using. So let's get back to these windows. So we know that these windows are bound on the top side and that they're equally spaced. So what we can do is copy this first one, right? And then once we have that second one, if we want to maintain this distance, what we can do is copy, but instead of referencing this new one, let's reference the old one for this spacing. So I'm going to reference the bottom right of the old one and go to the one that I'm copying from. So now, if I keep doing this, all of these will be spaced appropriately and evenly from each other. As you can tell, like, I might get off some distance every once in a while because of the nature of trying to draw on top of an image. But the main thing we're trying to take away from this is that all of these windows are spaced evenly. And as you can tell, I even went as far as extending past, and it turns out that this window at the very end is still following that same logic of being spaced evenly. So we can delete these two because there's no longer windows there. But this window at the end, it's significantly shorter than our typical window. And we can take care of that by shortening it with either the scale 1D, as such, or if I undo, when we highlight this object, these 4 points come up, and we can select these points and just move them that way. Those points are referred to as control points. Normally, you want to be very careful when editing your control points, but in this instance where we're being very particular about what we're selecting, we can easily manipulate things like that. We can even go as far as just manipulating one, as you see here, and it changes that regular geometry into something more irregular. And if we do, go back to our rectangle. And as I see, we have a series of 4 windows on the upper half of this house. And if I draw a little construction line or a little guideline, holding shift and tab to lock me in that direction, I can see that this window here lines up with the window above. So what I can do is just copy these 4 windows, holding shift locks me in the orthographic. If I hold tab, it locks me in that one direction. And then I can place it there. But as we see, these windows are actually taller with a mullion that runs in the middle. So what I can do is, again, scale these appropriately. And I'll just draw another construction line that runs through the middle here at the approximate midpoint of that mullion. I'm going to delete these unnecessary guidelines. And now when I select all of these construction lines, I can group them so they do not disappear or fall away from each other. And I can go into my perspective, rotate them to where they're actually oriented in the right direction. So I need to rotate them 90 to make them vertical, and then rotate them 180 so we can place them on this facade that we have shown here. I'm going to turn off those images. And again, since we drew this reference rectangle, I'm easily able to place it on the face of where that is. As we know, this building is very symmetrical. So another way that we can double check some things, maybe somewhere in a way that our plans and elevations don't line up properly. We know that these windows are centered on this facade. I can use that previous midpoint from my mullion guideline, line it up with the midpoint of this elevation. That way everything is lining up properly. I can ungroup. And then I'll be selecting these windows up here and group this lower section again. And then we'll move them to their face. As you can see, our drawing and our masking is a little bit off, but that's not a big issue for this point. We're not trying to be perfect. We're just mainly trying to capture the intention of the architect with their building, which was the equal spacing throughout. I'm going to expand my perspective now, just because we don't really need to work in any of the other viewports. And as we can see, we have a series of curves, which are 2D objects projected onto the surface of a 3D object. In order to start making wall thicknesses and windows for this massing, we first need to basically hollow the polysurface out or create that interior space. Because if we look at it right now, if I just explode this surface, the thickness of these walls is practically zero. It's the thickness of the line, which is not what we need. Referencing back to the plans and the sections, we can tell that the wall thickness looks about to be 1 foot thick. And we can create our wall thicknesses of varying different ways. The first way that I will show you, and again, after we get through all creating the wall thicknesses, I'll show you what to do with the windows. Taking a little bit of a different approach that I did in class, just so no one gets confused. So let's look at this one first. We'll do 2 different ways to create wall thicknesses. This first way will be drawing the interior face of those walls and splitting the object accordingly. We will also draw surfaces for the ceiling and the floor. For this purpose, we're only going to be focusing on this very top half. Everything that we're doing on this can be replicated further for the rest of the building. So what I'm going to do first is duplicate the face border, DUP face border. And all that does is duplicate this outline of this any selected face. For now, let's just select this top face, and now we have that outline drawn again. I'm going to create a new layer. Again, we should be mindful of keeping our layers in order. I'm just going to call this construction layer. Construction walls. I'm just going to make it green so it's really easy to see. Again, as I said, we're going to offset these walls or this curve to be 1 foot to be that 1 foot wall thickness. And all I did was type offset. As we can see, it's asking us a couple things. What's the distance? Through what points? So on and so forth. If we want it to be capped, the cap on that means, do we want it to be a closed curve? We do, so we're going to leave it as flat. And we want the distance to be 1, so that is good. The thing that we want to be mindful of, we want to keep the offset on the interior side of that curve. So as we can see, the direction that we hover the mouse according to that outline curve determines which side we will be offsetting that curve. So we want to offset it toward the center. And now we have two concentric curves, two curves offset from each other that are spaced 1 foot apart. Again, we can do something similar with this face. However, that is not necessary at this point. What I'm going to do now is explode this curve, and I will delete those 3 other curves. So now what I'm left with is this 1 foot offset in the center, as well as this one edge curve. Again, I'm going to move this curve down by pressing the gumball, and I'll move it down -1. That will be our construction line for the ceiling plate. And I'm going to copy this down to the bottom. Or actually, we can do DUP edge. We can select that edge down there, similar to like duplicating the face border of a surface. This duplicates a single edge. So now we have that new curve drawn for that edge, and we can raise it up 1 foot. This will be our construction line for the floor plates. So now what I'm going to do is just extrude all of these curves to be surfaces. So I'm going to extrude the curve, extrude it all the way through the building. That way I know for sure that it is intersecting at all points. I can delete those original curves. Again, I'll extrude this curve as well, except I do not want it to be a solid object. I want it to be just a series of surfaces. I will extrude that past. Now what we can do is start separating this once solid mass into a series of ceiling, walls, and floors. How we will do that is Boolean split. And I will split the the ceiling and floor first. And we can tell that now this middle part has been separated from the overall mass, which is good. Now what we're going to do is do the same thing, but for the walls. And then we're going to do Boolean split. Select the object we want to split. Select the thing that we're using to cut that object with, which is this previous extruded construction wall. Now we can delete all of our construction lines because we no longer need them. I'm going to temporarily hide this top ceiling plate, or roof plate, we should call it. Now we see that this box on the inside is separated from the mass. We can just go ahead and delete that. And now we have a completely open interior with 1 foot walls, a 1 foot floor, and a 1 foot ceiling, which I will unhide now. Just typing show. Now that we have that done, we can extrude these windows. Now we'll just extrude the windows as so. We can turn the solid on now. And we can, since we know that it's a symmetrical building, the windows are on all sides, we can go ahead and just extrude them past, and I will just Boolean difference these window constructions with the wall massing. If we delete them, now we see that we have these punched openings. However, this looks basically the same thing as the original building, except now we need to place windows. And if you look at the image for the tea house, we are able to know that these windows are actually inset from the face of the material in the exterior. I'm pulling up the photo right now. See, there's a little bit of a shadow there, so we know that they are not flush with the exterior material. What we can do now is just place the windows at the midpoint in this opening, which is kind of typical. And again, I'm just going to select those construction lines that we created earlier. And as a general rule, window mullions are typically 2 inches wide. And so when I select offset and 2 inches, it's going to prompt me with which curve we want to offset, which is this one here. Again, I'm going to go to my window layer just so it's all taken care of. And now we see that we have a 2-inch offset with our window opening. We can do this similar thing with this line up here, where it's dedicated for the middle mullion. However, as we see, it's offsetting in the XY direction and not the Z direction, or the Z axis. What we can do there is first we need to turn the both sides, because it's 2 inches and we drew this line beginning at the midpoint of that mullion. If we're doing both sides, though, the distance that we're offsetting is now 1 inch instead of 2 inches. So I'm going to type that accordingly. So on both sides, we're offsetting 1 inch. If we go ahead and just press enter, we can rotate this with the gumball using 90 degrees, so it's in the same orientation as the other mullions. What I'm going to do very quickly is just a curved boolean. Again, similar to what we've been using before, we can use this in any of the viewports. It's just a quick way to simplify this geometry. So as we can see, all these curves were intersecting each other. So we were able to use curved boolean, and then we're able to decide which part of the curves, which we're seeing kind of bolded, the dark bold, which curves we want to keep. I'm going to go ahead and delete all of those input curves. And we can see we're left with only these things here, which is the outline of our mullion. So what we'll do is extrude that mullion 2 inches, because they're completely square. Now we have a mullion that has, now we have a window that has a mullion in the middle. In order to create the glass, we can do one of two things, right? We can either draw a surface just from scratch, and just surface, or using that quick shortcut over here on the left. Just get a little finicky. Just keep in mind also in the middle of a command you can always change your display mode. So I changed it to ghosted now so I can properly see through. Oops. So what I did there is just create a bad surface. Can be a problem. You need to make sure that when you're creating these things, you go in order. You see, I went from the bottom left to the right to this top left, so I crossed the path. But I should have went from the bottom left to the bottom right, top left. I was going to go and delete that and do everything a different way, which may be a little bit simpler for everyone. I'm just going to take that curve that we have here, that we previously had for the opening and the mullion, and I'm just going to use planar surface. It automatically creates that surface for us. Typically, glass is in the midpoint of the mullion. We can either do it by dragging it there or moving it there, or since I know it's a 2-inch mullion, I can move it 1 inch to the inside. Now it is perfectly centered with that mullion. And I'll just do this other one quickly. Okay, now we have the basis of our windows. We can group them. So now whenever we're editing or moving this window, it all moves together. And we can copy them to the other window openings. As so. This can be copied throughout the other one as well. And that's one way that we can do windows as well as bifurcating a solid object to remove the interior portion. Another way that we can easily give this solid object a wall thickness. As you can see right now, since I have these two things, and I was previously focused on this first object, the second object is a little bit not centered on the camera. And how I can center it is typing ZS, which is zoom selected. Now it will zoom to that thing that I have selected and put that at the center of the camera. It can work for anything too. For instance, if I want to focus on this curve here, I can zoom selected. Now that curve is at the center of my zoom, the center of my camera. Now let's just center on the masking itself. This is a new method than what I showed in class today. Well, slightly new. In class, I believe I exploded everything and offsetted each thing separately. For this, though, we don't really need to explode everything because we're working with all these separate objects, separate surfaces, and you need to figure out how to join them together to make them solid. For this, let's just remove one surface. Well, I'm just going to choose this top. I'm going to hold Control and Shift. It will select that one surface. Similar to using the control points, if I just drag this, it edits the entire polysurface, right? If I just select it and delete it, it just deletes that one surface. Everything else is still connected or joined together. Now that we have an open polysurface, we can again use that tool or command we used in class, which was offset surface. Again, I'm going to be paying attention to what direction we're offsetting, similar to the curves. Offsetting in their 2D direction, surfaces will offset in their direction as well, but more of a 3D aspect, like we're seeing here. Right now, as we can tell, everything is being offset to the exterior of the building. That is not how we want this to be shown. We actually want it to be offset towards the center. And again, let's make sure that we have all of our parameters set correctly. The distance of 1, we want the corners to be sharp, not round. It's a very square building. We do want it to be solid. And yes, we do want the input open poly surface to be deleted. So we can Just press enter. And as you can see, we have easily created maybe a lot easier steps. However, we have a little bit less control over the entire thing. But that's one way that we can easily get wall thicknesses. What I'm going to do now is just merge these coplanar faces. And it kind of cleans up those corner geometries that we were seeing. You will notice that we are missing a roof now, which we can easily recreate by either drawing the curve and extruding it down 1 foot, or just drawing a box using the 3-point. Right, 1 foot. So again, we're kind of back at that same point we were before. We can extrude these windows and start modeling the interior walls based on what the floor plan is showing. Now that we've kind of understood how we can get wall thicknesses and how we can create the openings for the windows and doors, how to model mullions and glass and stuff like that, we can move into modeling stairs. Let me turn on my images. The stairs that we're going to be modeling are from the Villa Savoy. I'll pull up that plan right now. The ones that we want to take a look at are this set of stairs here, which may be a little bit complicated at first, but they're actually fairly simple. Rather than importing this into our model, I'm just going to draw it from scratch just by looking at it. So this is the set of stairs I created in class today. The way that I got there is I started with a box, which I can draw either by a rectangle, right? I specify in class that the typical stair requirements in the US are a 7-foot riser and an 11-inch, not 7-foot, 7-inch riser, 11-inch run. What that means is for every 7 inches of vertical height or rise, the distance moving forward needs to be 11 inches. So what that means is if we have a 3-foot stair, for instance, it needs to be at a width of 11 inches, and it needs to be extruded 7 inches. In order to easily copy this, right, we can either just copy each one at a time, so on and so forth, or we can array linear and select the number of items. Let's just say 6 for now. Now we have 6 stairs, all spaced evenly based on where we drew that array. However, this is just a straight run of stairs. If we want to get back to this kind of switchback that's shown in the Via Savoy, we'll need to copy and rotate, which I can do easily by holding the Alt button and pressing the blue radius on the gumball. That will create a copy when I'm rotating it. And then I can easily move this into place. But as you can see, we are missing a landing. I'm just going to draw that quickly. Landings are typically the same depth as the stairs are wide, which is 3 feet in this instance. So it's a 6-foot long landing, 3-foot wide, 7 inches tall. A landing also acts as a additional stair. As you can see, this last stair here and the landing are at the same level. So what we can actually do is raise all these other stairs up 7 more inches, and that is how we can use that landing as a stair. Um, the Via Savoy has a landing that has a radius to it. It's half a circle. So we can do that by selecting or doing the command circle. And I'm going to use, instead of just drawing the circle this, I'm going to make it a little bit more intentional by doing 3 points. So what 3 point will do is specify those points where I want the circle to be. For instance, that the two ends and the midpoint. What I'll do is extrude this curve and make sure it's not solid, because we want to split it with the landing. We don't want to delete this interior part. So I'm going to Boolean split, select the landing, because that's what I want to split, and I will select this cylinder to cut it with. And I can delete these objects. Now we have a semicircle landing. But as we can tell in the Via Savoy, this landing is actually bifurcated into 6 separate steps that are kind of shaped like little wedges or pie shapes. What we can do is draw a line, and we can array this line polarly, like array polar. And we select the center of the array. We select how many items we need. Because there are 6 steps, we need 7 lines. That way each step is bounded by a line. So 7. And the angle to fill, or the first reference point, I'm just going to draw it by selecting it. But we know it's 180 degrees. And we can kind of see this preview that we have right now, which seems correct. We have 1, 2, 3, 4, 5, 6 steps, all evenly spaced along the semicircle. I'm going to press OK or Enter to accept. Now I will select these curves, and I will extrude them, both sides, just to make sure it actually intersects all pieces of this surface, polysurface. And again, I will Boolean split this object with these curves, these surfaces. Again, it happened that everything got copied multiple times. That is probably happening due to where all these surfaces meet. I may not be liking exactly what's happening with the Boolean splits, but pay no attention to it. It is no big deal at this point. We can just copy these to their respective heights, or move them, I should say. And I will delete all those extra elements. And then make sure the rest of our stairs follow the new height Press move, make sure I go vertical. That way I'm restricting myself in the Z axis. Oops, I missed this last one. Vertical, move it where it meets. And it's easily snapping to these because I have my O snaps turned on. Crucial whenever we want to make everything precise. You can see I have basically recreated that stair I did earlier in class today. Okay, there was one other topic that we talked about in class, which was how we create this kind of curve that we were seeing in the hemisphere project. How do we create this curve that way it can rotate or revolve around this very radial uh, building or house? So what I did was create this initial curve, which I'll do again just by, well, first let me delete that original one. And I'll draw my construction lines, which is this base point, and then this straight line here, right? Looks about right there. And again, I'll draw my circle because this seems to be a very regular radius. I'll do my 3 points. One point being here, the other point being, I don't know, like right there, and finding where that line intersects, which looks to be right there. And now I have 3 curves that have no relation to each other. What I'll need to do is trim those curves. And I can select all of the curves actually in this step, because I'm going to be trimming all of them in with each other. And I'll select what side of the curve I want to trim, which is the underside of the circle, the top of this curve here. There's a little bit happening right there. So that looks about right. Now I can join these 2 curves together. I should be expanding the top view for this. Apologies. And I can offset this curve. Again, the distance right now is very small because that's what we were working with before. But for now, we can do 3 points. And we can see that the ends are actually automatically being closed for us. If we do not want that to happen, we can change the cap to none. And it'll just make another copy of that same curve, but at the distance you want. For this instance, let's just do the cap flat, and I'm going to specify the distance at that point there. Now we have this kind of curved rib shape, and I have drawn this guideline for the center of the building. I will copy both of those elements, not copy, but rotate both of those elements to be vertical, just so we can see how it will actually work in the building. And I can take this one construction line and type the command revolve. It's asking me to start the revolve axis, which is this guy that I drew earlier, and end of the revolve axis, or press enter to use the Z axis, which I'll just press enter. And then what angle do I want? How far do I want it to go? It depends on if you want to go ahead and revolve this entire thing around the entire hemisphere, or if you would rather just build it one bay at a time, and then you can array all those bays at once. For this instance, we're just going to do the entire circle. So I'm going to go up here, click full circle, and it has automatically revolved that shape around the entire circle as a closed polysurface. Um, I believe that is everything that we talked about in class, tutorial wise. There were a few tricks and tips here and there that people were encountering along the way that needed help. For instance, especially on the SESC Pompeia project, where we had all these overlapping archways, and we were trying to draw 2D objects along all these three-dimensional forms. Some points our drawings would end up becoming unplanar. It's just something similar to this, right? In order to make this actually on the XY axis, all on the same point, we can type set PT, which is set point. And this little dialog box should pop up. If we do not select anything, all of these points, all of these lines will actually combine into one point, one XYZ point, which is not what we want to do. Instead, we want to only have these oriented or be on the same Z axis or Z plane. So if we press the Z, then we can determine what Z plane or Z coordinate we want those points to be on. So now we have that rectangle that I was trying to draw earlier. Similar, we can do it for the X axis, right? Or even the Y axis, just depending on what axis you're working at the time. I believe that was everything that we talked about in class. Another quick thing, like making sure that you're drawing everything at the right elevation. For instance, the SC Pompeia, one building is oriented at 90 degrees and the other one is oriented like at a 45. But the elevation shows them both kind of flat. But you'll notice in the elevation, you see one building face forward, you only see this one elevation. While the building next to it, you see both of these two elevations. And at this one elevation, you have a series of organic openings. If you were to just redraw that elevation as it's shown there, like if I look at it on the right view here, if I were to just redraw this as it is and try to rebuild that with my existing massing, it would not be at the same scale in the x-axis. So whenever I have those elements drawn, right, I'll just draw a circle in here for right now. I'll need to double check to make sure that these are scaled appropriately to match the distance of that side of the building. That overall concludes this tutorial. Be sure whenever you're modeling to have very clean layer structures. It will aid you in the future whenever you start rendering and assigning materials to these various objects. For instance, everything is on your default layer, and you're trying to specify what is a glass object versus a solid, like core tin object, like what's shown on the tea house. It'll be very hard to distinguish or assign those properties. So if we start building the layers how we need them in the future, we'll get in that mindset of only windows are on this layer. It also allows you, whenever we're looking at this, we can easily turn off that window layer and just see the massing itself. Okay. Everyone have a great weekend and hope to see you in class on Tuesday with any questions or problems that you may have encountered over the weekend. Okay, see you then.